All right, good morning, everybody. Just to check, like always, can everyone hear and see me?
Yep.
All righty. We have finally arrived at our last chapter. If you feel emotional, I will pause for you to get some Kleenex, but we are close to the end. No, I'm the only one that's sad about that. Okay, I understand. Let us continue. Chapter 17. Area and volume. Area and volume. Now, we're not going to do this in one sitting. We don't have to rush at all. So we'll just do the first little section. So when it comes to the concept of perimeter, I'm just going to put it right there at the top. The perimeter is simply of a shape, of a region, of a polygon. It's the length of the outside. So for a polygon, it's the sum of all the side lengths. So we'll just do it by example. For this triangle in exercise 17.1, the perimeter is the sum of all the side lengths, which means I need to find all these lengths in this triangle, for example, and they give me one of them. So let's copy this triangle, 17.1, example 17.1 triangle. It is a right angled triangle. I have 1 and 30 degrees as some information, then a B and a C, and I might not care about the angle, to be honest. In order for me to find the perimeter, I need to find these other lengths, which is a familiar question going back to the trigonometry section. So I could, for example, find B by looking at the angle 30 degrees and seeing, well, I have an adjacent and an opposite angle involved. Let's say here to find B. One option is to say tan of 30 degrees will be opposite over adjacent. So that means that B is 1 times, or just tan 30. So we can calculate tan 30. I will ask MathBot to do it. And we get 0.58, let's say. Let's say 2 decimals would be fine. So 0.58. Now to find C, you do have some options, so it's good to be aware of those options. That I could just use my angle and my given information, and that will then require the trig function cosine. So cosine 30 will be adjacent over hypotenuse, and I can then find C as 1 over cosine 30. I can calculate that, or or we can use our newly found perpendicular side B and Pythagoras to say, well, 1 squared plus whatever B is squared will equal C squared. So C squared will be 1 plus 0.58 squared. So C will be, let's get an answer here, and then the square root of that. Now, it is a little bit risky if I use my 0.58 as it is because that is a rounded value. and it's hard to know if I use a rounded number in future calculations, how many of those decimals I systematically lose. So it's best to use the perfectly accurate tan 30 or all the decimals that I see. That would then be as the inside of my square root 1 point, well, of course 1.5, 7735026 9, and I'm running out of space. I can round my answer to present or as a final answer, but when I use an answer in a future calculation, make sure it's the most accurate version I have. If I then take the square root of that in here, what do we get? I haven't done cosine yet. I'm just doing the Pythagoras side first to illustrate the awareness of rounding. I didn't square it. That doesn't sound like some mistake I would make, but I'll give you the benefit of the doubt. Let's make it super clear and say 1 1 squared plus, I'm sure that's just a mistake that MathBot made. It wasn't me at all. Erasey time. So what do we get? 4 over 3, that's nice. 1.3 repeating. That goes in there. So the square root of that is next. And we seem to get 1.1547 and so on, which is our final answer, which we can round. Let's check the left side. If I go the seemingly simpler, but with trig functions, root 1 over cosine 30, if MathBot is playing along, that should be the same, and it is. So I get 1.15 for C, and now we can calculate the perimeter. Perimeter is then my 1 plus my point 0.5, whatever it is. I can present it as an answer, rounded, plus my 1.15, and then you can go ahead and you have your answer. So the concept of perimeter, super easy. I happened to see it, was it yesterday or the day before, in a grade 3 workbook, uh, where of course they don't do this level of calculation, but the concept of perimeter is introduced fairly early. And then the complexity goes up with the grades, but the concept stays the same. So of course it depends on the shape. I can use Pythagoras and trig functions for a nice right-angled triangle, but that's not always going to be the shape that I have to work with, of course. Let's see what else we have here. We have another triangle. I don't know if we really need to do this triangle. It's exactly the same situation. I'm going to leave that for you to practice because the method is pretty much the same. I prefer to stick with the given information, the angle and the the given side to find the other sides so that I don't have that rounding issue, which can be a little bit of an issue, a hassle more than anything else. We can, of course, do other shapes like in exercise 17.2. Now, the first one's a parallelogram, which I'll show you in a second, but it's again just perimeter questions. So, first, are there any questions on the triangle while I set up 17.2? No questions, I suppose. So my first one, I'll just show over here. I'll zoom in a little bit. That's what it should have looked like. Or I just got another parallelogram. We want to calculate the perimeter. Now, most of you did the pop quiz already, and the area calculation involves this distance between the parallel sides or the height of the parallelogram, call it whatever you will. But the perimeter is not the same as the area calculation, of course. We're only interested in the side lengths. And this side is going to be a 5. That's a really big 5. 5 there and 6 there. I'm just going to put it right on top of this. No, I guess I shouldn't. Perimeter is then just going to be 2 times 5 for either side and 2 times 6. Perimeter. So the concept is fairly simple if I have all the sides given, sure. 2 times 5, 2 times 6, so that's 22. Just hold on 1 second, I'll be right back. All right, I'm back. Where did I get the 2 from in the parallelogram question? There are 2 5s and 2 6s, one on either side. So yes, you of course can say 5 plus 5, sorry, 5 plus 6 plus 5 plus 6, but that is exactly the same as what we did. So it's totally up to you. You can list them all, you can group them together if there are similar numbers. It's totally up to you. The point is, I have to go all the way around the parallelogram and add them all up for the perimeter. How you write them is completely irrelevant. Don't think of it as a formula. Think of it as looking at the shape and adding up the side lengths. I specifically, where I can avoid it, want to not think about just plugging it into a formula and think about what perimeter means, which is how it's introduced in elementary school as well. You have random, non-regular, irregular shapes, and they simply go and count the side lengths until they go all the way around. So I want formulas are coming, but I want to avoid it as much as possible. Where for area, it wasn't as simple, right? Because it was slightly skewed object and I couldn't count area units as easily. All right, so this is one of many shapes. Let's see, trapezoid is there. Okay, let me copy this trapezoid for number 2. And that buys us some time if there happen to be some questions as well. There's my trapezoid. These are, whoops, These are, of course, the parallel sides. 3 at the top, whether it looks like it or not. 10 on the right side, and 8 and perpendicular 7 down. All right. So I need to simply, I have 3 of the sides. So the only goal is to find what is this bottom length, this bottom side's length. Now, I can break it up into this portion. Then I can make another perpendicular line down and have that bottom side broken up into three, three pieces. Let's call this piece 1, piece 2, piece 3. Maybe not like that. Let's call it ABC maybe. Let's call it A, B, C. Maybe that's better. Yeah. So hopefully everyone agrees that once I have A, B, and C, then I'm pretty much done and I just go around and add up all the lengths. Now, how I find the A, B, and the C. Is any one A, B, and C immediately obvious? Let me ask it that way. Is A, B, and C one of them immediately obvious and I can just fill in the number for one of them at least?
B is 3.
B is right away 3, so I don't even need a B to be honest. There's a 3 there because of the perpendicular sides and that middle rectangle that I'm making. So that's a 7 and that's an actual square there. So A and C will require me to look at a little right angle triangle with Pythagoras. So for this left one, I have 8 squared equals A squared plus 7 squared. Now this is not to scale or anything. A might be really small. A squared, let me move up a bit, is therefore 8 squared. Oh, it's good arithmetic practice. A squared is 64 minus 7 squared, which is 49. So A is the square root of, pause for dramatic effect. Anyone? It's just me talking to myself. This is awkward. Left to right, yes, indeed. It's good to contribute.
Are you like looking for the answer
I'm
15?
looking, yes, I'm looking to not awkwardly talk to myself for hours. I'm very insecure. I need that validation, right? So now I can't look at your faces for validation anymore. So I need actual verbal or textual validation. We'll calculate that in a second. Someone has feedback here. As much as I do like listening to myself, someone's feedback. You're always the problem, aren't you? There you go. Okay. Now for C, it's going to be exactly the same. The 7 carries over here. It's going to be however you want to write it. 10 squared equals C squared plus 7 squared. So C squared equals, and I just call it C. I can call it anything I want. It doesn't matter. It's going to be 100 minus 49. So C is then going to be the square root of 51. And we can calculate these, or actually don't even calculate them. I don't even care, because if I calculate them now, I have to round them. Then when I add up for the perimeter, I have to remember to use the accurate numbers. Maybe don't even calculate them now. Maybe it's a waste of time, to be honest, because it's just a means to an end for this bottom section. I don't need to have the side length for the bottom side. I just need to go all the way around. So let's start on the bottom left, for example, and go clockwise. 8 plus 3 plus 10 plus root 51 plus 3 plus root 15. And then MathBot can hopefully find that for me. does it say? It says 35.01. Now I'm not sure what the units are, but there we go. Now I don't want to go too fast, though perimeter should be a fairly straightforward concept for familiar shapes. Shapes where I either have all the side lengths or I can fairly easily find the missing side lengths. But let me know if there are any questions. My polar bear is going crazy. What is happening?
I have a quick question, Stephen.
Yes.
I'm just wondering, when you do Pythagoras, how do you know what order to put the numbers in?
The two perpendicular sides always go together on one side of the equation.
Oh, okay.
So it really doesn't matter how you start, but the hypotenuse is alone on one side and the perpendicular ones are together on the other side.
Oh, okay. Excellent. Thank you.
So it's better. I know some people think of it, oh, a squared plus b squared plus c squared, and they're so attached to those letters. Instead, just think about which pieces of the triangle go where in the equation, and then you're and then you're much more flexible.
Okay, thank you so much.
All right. So let's see what else we got here. So I'm done with my parallelogram. I'm just going to delete tabs so that I know which ones I still have to do here. Parallelogram. So now those are familiar shapes, but obviously we have other polygons. So let's keep it simple and make them regular. Then we're not going to derive this because the trigonometry gets a little messy. But I'm going to eventually have to get a formula to cover fancier shapes. So what this is the formula for what area? No. Yeah, so let me just backtrack, sorry. So if I have polygons with more sides, then I do have perimeter formulas, but they get a little messy. Uh, for our level, what we require of perimeter is simply adding the side lengths together, maybe a Pythagoras or something simple. So we're not going to worry about looking at formulas for perimeter when they're never going to really come up to justify memorizing formulas. But when I go to area, then the a formula is maybe a more useful one to look at. If we're going to memorize one formula, then the area formula should be it. So perimeter is pretty simple, add up all the sides. So now we're going to shift to area. Area. So if I look at a regular polygon with n sides, could be a square with 4 sides, could be a pentagon with 5, but there's no limit. I have a general formula to cover any regular polygon. I just need to know how many sides I'm interested in. I also need to know the side length, which will be given. Then the area can be calculated by this formula. So the side length, and they're all the same side length, squared, and we're going to use this formula in the next exercise, times the number of sides, n, divided by 4 times the tan function, and the input of the tan function is degrees, 180 degrees divided by n. If you're really curious, I can give you a general idea of how this formula is derived, but actually deriving it is going to take us at least 30 minutes, and it's going to distract us from our focus, which is just um, getting used to using a formula when it comes to area to be able to handle something more than a square and a rectangle and the basic ones we've seen before. The downside is that it has to be regular. This is literally one formula. It's the only, well, it's not going to be the only one, but for this level of complexity and appearance, it's going to be the only one. I'm avoiding all the perimeter formulas because it doesn't really, it's not necessary, it's not beneficial to us, though the area one has some benefits to just keep those brain cells working. So now let's just look at exercise 17.3 to see the pieces of the formula and how it works. Now remember, do keep in mind here that any upcoming tests are open book tests. So there's no memorizing of a formula. You just need to know how to use the formula. So it's really all good news. There's really nothing to feel discouraged about here. So in exercise 17.3, let me set it up. Let me set this up. People get discouraged until they realize, oh wait, I can look up these formulas. So in hindsight, actually, we should have a bunch of formulas because we don't have to memorize them all. Oh well. Exercise 17.3, I believe that is. Was it? 3? Yeah, okay. So it says, instead of giving me the shape, draw a square with side length 3, whatever the unit is. So I can draw that. So all the sides are 3. 3, 3, 3. Now, of course, I know what the area is. It's 3 times 3. It's 9. But I want to test this formula and see that it works for the basic ones as well, and then also works for fancier polygons where I don't know any other way. So this is the um, portion we know. Now let's see if the formula gives us the same area, which it should. Now in the formula, the number of sides of this regular polygon is 4. The side length is 3. So my formula says, let me just copy this down, s squared times n, whoopsie, over 4 times tan, 180 degrees over n. Okay, how is that going to work? It's going to be 3 squared. I apologize for the lawnmower in the background. There's not much I can do. I'll try and speak less. So the 4 in front of the tan is always a 4. Oh, come on, where is this page? This is always a 4. N, the number of sides of the regular polygon, happens to be a 4 in the case of a square as well. Is everyone happy with how and what I plugged into the formula? No one is happy? Wow. One formula and everyone is unhappy? You don't have to memorize this formula. Okay, good. Now, we can simplify the inside of the tan function. 180 divided by 4 is 45 degrees. That will make my life a little simpler. I can simplify the top. I don't have to. I can just calculate it as is. Let's see what MathBot does. Let me use brackets. Like so, and oh, big surprise, it is a 9 as well. Question there, are we able to use this when the sides have different lengths? No, it has to be a regular polygon. So we're not going to look at shapes higher than quadrilaterals unless the side lengths are just, oh, for area. We're not going to look at anything that's not regular past quadrilaterals, for which we have the pop quiz formulas already. So if I open it up to any size polygon with any kind of sides, then it just becomes a whole mess of stuff. So we're giving it a lot of structure in order to get a handle on how things can look moving forward, but let's not move all the way forward. You have to input the degrees, the angle in your tan, and you have to say 4 times. I know it's MathBot changes what I typed. I didn't type it like this. Between 4 and 10, I put a time symbol, but MathBot presents it in some sort of simplified way. So it looks as if I didn't put that in, but I did put a time symbol in between. That's just MathBot being quirky. You have to put an actual times in there, of course. I know, it changes it automatically. I don't know how to change that. What I typed in is the following. Uh, 4 times. Oh, it didn't put in the little... Man, it simplifies it automatically. Wow, I don't know why it does that. Yeah, I put in my time symbol, but it just removes them. In between the 3 to the power of 2 times 4, it removes them. I don't know why. I don't know why. My apologies for that. It's something in the text does that to a time symbol. I could use an X, but then it looks weird. Anyway, we'll write them out on the screen, and then you can just make sure you are using at times where there is written at times, even though the chat result doesn't look right. So I do get the same answer. That's good. So I'm beginning to trust my formula a little bit more. What is the next one? That is an equilateral triangle with side length 2. Let's move up here. Number 2, triangle. Of course, this formula only works for regular shapes. So side length 2 and 2. Now, one could take this, and for the triangle area formula, I need to calculate the height, which, because it's an equilateral triangle, is going to split this equally. I can then calculate, and I know this is 60 degrees. I can calculate this height, but that seems like a lot of work. I can certainly verify it that way. So there is an overlap between the basic um, polygons that we've seen before, 3 or 4 sides. I do have formulas for those already. And now the formula is sort of an overlap once it crosses over to the larger ones. So the formula allows me to not even worry about the height of the triangle. It's going to, in case we don't remember yet, take the side. So let's say here. So n is the number of sides of the triangle. 3. S is the side length. Then they're all the same. That's at 2. So the area formula takes the, let's copy it again, s squared times n over 4 times tan of 180 degrees over n. By writing it down, I end up memorizing it a little bit automatically without trying. So it's going to be 2 squared times n, which is 3, over 4 times tan of 180 degrees over 3, which I know simplifies to 60 degrees. So let's try whatever calculator you are working with. Let's try it again. So it's going to be 2 squared, which I could just put in a 4, and I could simplify the top just as a 12, but you don't have to. Divided by, I'll put it in brackets. 4 times tan, and I get 1.73. Can anyone confirm the 1.73 with their own calculator?
Yep, that's correct.
Okay, good. So by doing this a couple of times, we get a feel for the formula, and the more you do it, the less intimidating it becomes. Now, this was a crossover. If we go to a polygon that I don't know how to calculate the area without perhaps a lot of effort, breaking it up into triangles, like a pentagon with side length 1, I can practice my pentagon drawing skills as well. Not great. I'm just going to go with that one and indicate that they're all the same side, just in case it doesn't look like it, which it clearly does not. I think my straight line tool messed me up a little more than I wanted to. N in this case is a 5. S is the side length of 1. So my area, again, I write it down so that it helps me to memorize. S squared times n over 4 times tan of 180 degrees over n. So that will be 1 squared times 5 over 4 times tan of 180 degrees over 5, which we can leave like that. You can simplify that first. It really doesn't matter at all. So let's do this last one. Again, I can simplify the top to just a 5. Whoopsie. See, we have the 5 at the top divided by 4. Now it shows my times. Times tan of 180 divided by 5, brackets. Can anyone confirm my answer of 1.72? 1.72. When I round it, it's my final answer. Okay, so hopefully we get a little bit more used to the area formula. I don't want to look at many formulas, but there are some formulas um, that is worth just getting used to how formulas can be used. I don't, of course, have to memorize these because I can just have it in front of me and look it up. Any questions so far? My polar bear is doing crazy things. Not sure. Yeah, any significant questions we can certainly address um, at any later time as well. Okay, so we have a way to calculate the area of a regular polygon given the side length. And there are other formulas, like if I don't have the side length, and all kinds of things. But one formula gets us the idea, and that's good enough. So let's zoom out here a little bit. Next, we want to explore the circle. Let me just move this window so I can see what we need to see. All right, there we go. Okay. Do we have enough space for the circle? No, very much not. Did you not make the page, or you're just unhappy? It, it is unhappy. Why are you unhappy? Oh, no, it did it. It just didn't show me. Okay, so next up is the circle. My computer seems to be unhappy about the speed at which I'm working, apparently. So when it comes to the circle, circle formulas are very important to know. If you're going to memorize formulas and know them well, we want to know triangle and rectangle formulas, and the circle is certainly up there. But instead of just memorizing the circle formula, I want to get an idea of, still fairly informal, of why the circle, the formula for the area is what it is. So to sort of help my understanding, which then helps me to remember the formula perhaps, I want to notice that I can break a circle up, not break a circle up, I can look at a polygon inside a circle to give me an idea of the area of the circle. It's not perfect, but it's going to be an approximation. Let me illustrate that here. So if I look at this, uh, if I look at this, now don't worry about the words here. I can't get rid of them or anything on the right here. I have a circle and I can put a triangle inside it. Now the triangle area is not a good approximation for the area of the circle. There's a huge gaps over here. But if I increase the polygon, then you see the gaps that I'm missing when I calculate the area of the square and use that as an approximation for the area of a circle, the gaps do go down. If I go to a pentagon, the area of the pentagon is a better approximation for the area of a circle. Still not great, but the further I go, the better my approximation becomes. If I go to 7, it gets better and better and better as I go. And the little bits that I'm missing in my approximation, they do go down. So then it's definitely conceivable that if I keep going and going, they jump to 30 on this website. I almost can't even see the gaps anymore, even though that 30-sided polygon is still there, and I am making little errors all along the sides because it's not a perfect circle. I can't even see it anymore. It's on this diagram. So the larger the number of sides of the polygon, the better the approximation is going to be. So this is going to be my idea. So let's look at maybe something that's a little easier to draw. And let's look at that uh, version, that approximation specifically. I have it somewhere over here. I'm just looking for the tab that I am interested in. I took a screenshot. There it is, so that I can draw on it. Okay, there we go. Now I need to make a smaller pen. But not bad. Okay, let me go pick a color as well. Maybe this one. I like this one. Let's go pink. Easy to see, pink. Okay. So forget the words here. I can't get rid of them. So what we're going to do is we're going to break this pentagon up into triangles from the center of the pentagon, like this pink triangle. And I'll have a bunch of them. And of course, I can do that for any polygon that I have. The more sides the polygon has, the more triangles I'm going to get, and the smaller they're going to get. If I look at the pentagon versus uh, another better approximation, like this one, you see my triangles are getting smaller, but still I have a number of triangles, one for each side of the polygon. So let's just focus on this one, for example. Which page is this? Can I drag it? No. Okay, so let me just set this up. So I want to black. Thank you. I want to get an idea for the area of the circle. It's going to be an approximation, so I can't say equal. I use these squiggly equal signs for approximately equal to the area. I need to write slowly. This drawing program is unhappy with my speed right now. The area of my polygon, which has n sides, I can choose a 5, or I can choose a 9, or I can choose a 30. The higher the n, the better the approximation is going to be. So now I need to approximate, or now I need to get an idea of the area of this polygon, but, oops, no, not that. Where am I now? Over here. But I don't have its side length, right? I can approximate it by way of these triangles, and there's going to be a number of them all the way around. So for a for this, which is 7, this is a heptagon, I'm going to have 7 of these pink triangles. If I can find the area of one of them, then 7 times that will be the area of my polygon. So it'll be however many sides I have times those pink triangles. So area of the interior triangle, those pink triangles. Now I know the area of a triangle, so the n carries down to the next step. The area of the triangle is a half times the base, I'll write them out, times the height of the triangle. So I'll keep the n with me for now, and I'll keep the half with me as well until a later step, and I'll keep the base with me as well. So those all have times in between them. The problem is when I look at this diagram, the height is going to be over here, called the apothem, but it's not immediately obvious what it's going to be. However, as this is just an approximation, as my polygon sides increase, this polygon is going to get closer and closer to the circle it's trying to approximate. And the triangles, these pink triangles, are going to get really thin to the point where the height of the triangle is very close to the radius of the circle. It's an approximation. It's not exactly the same, but it is going to get closer and closer and closer. So we have another approximation where the height is approximately the radius of the circle. Radius of circle. It's not exactly, but the higher the number of sides of the polygon, the closer this approximation, the better this approximation is getting. Okay, so now I'm just going to reorganize these things a little bit. I'm going to put the half in front. I'm then going to put the radius there. And then I'm going to just focus on grouping the n and the base of the triangle together. Now what happens to the base of this pink triangle in this seven-sided shape? So n is 7. If I take the base 1, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, I get the perimeter of the polygon. So n times the base of the triangle is exactly all the way around the polygon. And the higher the value of n, the more sides I have, the closer that is going to be to the circumference of the circle. And we're almost done. So this is approximately the circumference of the circle. So I have my 1/2. I'm struggling to write. This is very blocky, choppy. My radius. Circumference of a circle is 2 pi r. And now I have the formula. The 2½ cancel, and I get pi r squared for the area of a circle. So I feel it's nice to see the slightly informal argument with an approximation. There's some calculus behind the scenes um, of where the area formula comes from for a circle. But I've noticed that we are kind of out of time. So our actual example where we can now use this formula We'll unfortunately have to wait until tomorrow.